Good afternoon. My name is Chetan.
I'm Pratyush.
And, okay, there we go. So we're developers in the mobile team, and today's talk is about what we've done at Flipkart to make mobile retail work at scale. We'll start off with a short video. We think it's really cool.
So you're saying I can now shop from anywhere?
Of course, with any place.
But how is it possible?
Flipkart के mobile shopping app के साथ.
Shopping is gone to another level now.
Welcome to the future, bro. ये देख. Search, swipe to compare, select, choose payment option.
It's very cash on delivery.
Happy birthday, Mr. Malhotra.
Introducing Flipkart's mobile shopping app. अब Flipkart करो कहीं से भी. Flipkart.
So that's a pretty cool app, and we're really proud that it's out there. But our question today is, what's in an app? I mean, some people say $19 billion, but as far as I'm concerned, any guy with access to Android SDK can go and create a really cool, fluid UI with lots of pictures and flyouts and cool flows and stuff. That's not a big deal, according to me. What's actually important is it's not the ability to create this UI, but actually to deliver content for this UI, anytime, anywhere, and to anyone. That's a huge deal. Why? Let's cue the numbers. So a recent survey said that a mobile user is really impatient. Only 16% of users will come back to an app if it fails to load fast. Now we have to define fast, right? So they defined fast as well. They said, okay, how fast is fast for you? You look at the graph. 2 seconds, they're saying that's anything more than 2 seconds is too slow for me. And what this means is, in a country like India, where including broadband connections, our average speed is 0.9 Mbps. We have to be really, really good on the server side to deliver content. And 2 seconds on the app means less than a second for us on the server.
So given all of these constraints, we have actually seen 75% growth month on month. Now that's a huge scale at which we have to work.
And we've got some pretty good reviews on this as well. People are saying that this is the best shopping app ever. I mean, they realize that this app is what makes them enjoy their smartphones. The reason this works.
And in order to maintain such high rating, you actually, and given the scale at which you have to grow, so if you can see over the last 4 months, we have seen a steady increase in the number of users. But if you see at the average traffic, that has gone much more exponentially. What that means is when you add a new feature, you're adding much more number of page views per visit. So as you add new features to it, you have to keep, you cannot actually breach the SLAs that you have defined. You have to keep on improvising on those.
Oh, and there's the whole push notifications thing as well. Everyone likes to get a push notification. And when you do get a push notification, everyone comes to our server within like an hour of getting it. So we get 5 times traffic, sometimes 10.
At minimum of 4 times the normal traffic that you actually see during that day.
And our servers need to handle that. So we've made a few design decisions in our system to kind of handle this. One of the things is we wanted to keep it simple. We don't want to keep it very complicated. So we went for a simple Java-based REST implementation on the server side.
And so you must have already seen that a lot of companies are starting to migrate towards native apps. The reason being, hybrid apps have a very fast development cycle. However, the user experience is not as good. On the other hand, native apps have a very good user experience, but the development cycle is very large. And at the same time, when you are actually changing the layout in which you show the homepage or the other landing pages, you cannot always create a new app and deploy it to the Play Store. So you actually need to control all the layouts from the server so that you don't have to deploy every time a new app to make a change.
Right. And when you're sending all this data from the server, you need the service calls to be fault tolerant. We connect to multiple downstream services. If any of them go down, we should not go down. We can't afford to give that bad experience more than 2-second launch time for the users.
Also, we set ourselves very aggressive timeouts. What timeouts means is, since we are making numerous service calls, we cannot afford to breach the SLAs defined for that particular service. So let's take an example of, say, product rating. So I actually open a product page. I expect it to load in, say, 1 second. Let's say the whole product info, I already have a product info. Now I want the product rating. Now let's assume I've defined product rating to have an SLA of, say, 100 milliseconds. if it exceeds anything more than that, we can very well remove the rating from that product page. We don't actually need to give a very bad, we don't need to give a bad user experience to the user.
Right, and these heavy calls that we have a lot of caching that happens. And because this is a distributed system, our distributed caches might also fail. So we also have a backup for that. We cache locally as well.
At the same time, you would also want runtime configurability from the server side as well as the client side. So let's assume a case in which there's high traffic. You want the data to be cached. If you want consistency, you don't want data to be cached. So all of these runtime configurability can be done from the server side. So that's the kind of design that you have to come up with for your backend to scale up.
So we call our approach widget wizardry. I don't know if this is a term, but we just came up with it. So what we're trying to do in our layout is create these small little standalone bite-sized pieces of information so that we can stitch these things together and make it really nice. What are the advantages? So we can personalize things. We can say, oh, Chetan's opening his app. Let me show him recommendations first. We can say, here's something that, he's a guy who's coming in on a 2G connection. Let's do it on demand. Let's send him one widget at a time.
Now you have widgets, you have configuration. You can easily implement an A/B framework on top of these. You can reuse components because you can use the same component and put it in different layouts to give a different meaning to the whole widget itself.
And most of our users, about 60 to 70% of our users, are just sitting at home, they're bored, they're just browsing through the app. So for the casual browser, we need to get them to what we want to showcase really fast, which means that if we can put these objects out there saying, oh, here's a cool image, here's the price, here's an offer, it's very easy to get them engaged and have them coming back to us for more. So the widget wizardry is what gives us these really nice looking, cool UIs.
And if you observe, all of these widgets are actually used in different pages with a different meaning to it.
Right. So this is nice. This is the wizardry part, but there's actually a lot of building that happens behind it.
So this is an overall, the high-level architecture of the backend that we have come up with. So there's the basic REST controllers on top where the APIs enter the backend stack. Now each of these API calls actually translate to one of the pages. So let's take the example of a home page. Next. So in this home page, you can see there's a card, there's banner, there's a horizontal scroll, there is offer widget, there are deal of the days, and many more. So all of these components are actually independent of each other. You can always compute all of these parallelly without having to wait for so all of these are actually mutually exclusive of each other. So these page builders distribute the work as well as aggregate the response from each of the widget builders.
Right, and the next level below that is the widget builder, which actually makes the service-specific requests to build up that particular component. And then we have our fault tolerance layer, which is the in-house Phantom. I'm sure most of you would have heard about it by now. So Phantom is what gives us the redundancy and the fault tolerance. And it gives us the ability to say, I don't really have to code up the fallbacks for this particular service when it goes down. Those are all taken care of by Phantom. So it's a really cool system that we use. And below that is whichever downstream service is doing its stuff, the task-specific logic is underneath that, and it's all abstracted away from us. So that we don't have, all we have to do is say Couchbase get, and the Phantom layer is taking care of going to the Couchbase, making the connections, bringing all the data back, formatting it, and all of that. So we call these Lego blocks. It's one of the coolest things that we have in mobile APIs.
Now, if you look at these, so there are actually various points where you can actually cache the whole data. So there's the URL caching right at the REST controller. Then there can be URL, then there are caching on the widgets level, depend on the behavior of the widget. So like a banner, which changes very frequently, you don't want to cache that. There's offers, you don't want to cache that. There's the horizontal scroll widget, which you can easily cache. And then there are service level caches as well. So this architecture helps you cache each of the components individually without having to worry about getting up with the whole page with a bad performance.
But of course, with any distributed system, we have to have monitoring. And what we use mostly is Phantom's dashboard, which gives us how many threads are active, what's the current frequency, how many hosts are up, how many hosts are down. And this gives us, in real time, a very good picture of what's happening in our system, and we can take corrective actions immediately. Usually we have a response time of what, less than a minute to go and fix a
Easily,
problem.
yeah.
So this is one of the things that we do. But of course, there's no such thing as an end to optimization. Like Gaurav was saying, our app is apparently making a lot of network calls. So, I mean, it's a work in progress. We're always working on fixing things up.
So that brings us to a very that brings us to a debate of availability versus consistency. Now so what we have realized over the few months is that you need both of them. You cannot actually bank on any one of them. Let's take an example in which you're sending out push notifications to the user. You are expecting about 70% of your user base to land on your homepage. You cannot at all afford to have your homepage down. So that is where you need very high availability, but you may not actually consider consistency as a very high attribute there.
Right, and there are sometimes when you have a targeted offer. Moto G, is it in stock or not? That was a big question that everyone was asking us on that day. We had to make sure that we had the most accurate information at any point in time. So that's what our variable caching is all about.
So we already talked about the constraint that a user has. In India, a lot of users are already on 2G itself. So you need high resolution. At the same time, for an e-commerce app, you're mostly working with visual representation rather than textual. So you cannot actually afford to give out high resolution images to the apps which are on 2G. So the app needs to actually be much more knowledgeable as to which resolution it has to pick up. Like the example Gaurav took up, probably he was on a high Wi-Fi network. So that's why the consumption was much more.
Yes, we've optimized that. Yeah. The next question, this is the other paradigm. There's an easy way to scale up. Just keep adding boxes, right? I mean, Amazon has a whole elastic cloud. Why don't we just use that? The problem with that is, first, ops guys will kill us. They'll say, why are you making us spend so much money? The other question is, how do you maintain all these boxes? How do you start deploying? All these kinds of scalability problems come up in the maintenance. So we have software-specific optimizations.
So there are, various good practices that you can follow to have a much efficient software. At the same time, you can actually batch up calls and give app enough content for it to render the current page as well as probably partial of the next page, so that the user doesn't experience the lag between transition to different pages.
Right. So this is a fairly big system. We've had a lot of code. And that brings us to the next one, which is we couldn't have done it without all these awesome projects out there. So this is our slide of thank you to all the great work that's happened out in the world. Trooper and Phantom are really good libraries that we use for all our redundancy levels. Spring gives us so much out of the box. It's just amazing. Couchbase, where's that? Hystrix, and so Couchbase is our memcache. Hystrix is what we use for all our commands. Google's Guava libraries give us really nice APIs, clean APIs. Adobe Omniture is really good for all our analytics. MySQL and MongoDB for our data sources, and Nagios for all our alerting. So thank you guys, all the developers out in the world who have developed these. We're really grateful. So we are done?
On time, yeah.
On time. Thank you. And Prashnigodu. I wanted to bring some Kannada into this talk because you're in Bangalore, but thanks. Any questions? Ask me a question.
Was it that?
Yeah. Right. So that's a very good question. So one of the main things that we're going to take up very soon is the localization. There are a lot of challenges with it. All our caching strategies will go right out of the window. So we're looking at those, and the next few months we're going to come up with some strategies for that.
Not very soon, though. I mean, is there in the plan?
Yeah, we're already working till midnight, so. Yeah. Right.
How exactly is your client-side app built? So if it's going to pick up stuff from dynamically. Right?
So before we actually deploy an app to Play Store, we actually define list of widgets that particular version of the app would support. And same works for Android, iOS, and Windows. So once you have defined a protocol between the server and the apps, the server can actually, so the server has to adhere to those set of properties. So we have a model, and depending on the client, we wrap the whole model into that particular widget and give the response. So we don't keep on adding list of widgets. It's just we freeze a list of widgets before an app is released.
So most of your views are very generic.
Sorry?
So most of your views on your app are mostly generic views, right?
Yeah, so if you look at the homepage, there's a cart icon, then there is banner, there is a horizontal scroll, text widgets, title widgets, merchandising widgets, and so on. So yeah, very, very generic, very generic.
Guys, time up.
Okay. There's a question. We'll come to you, Jaydeep. Thanks.
Thank you.
Thanks, Pratyush and Chetan.